Bismillah ar-Rahman ar-Rahim. This is a question October 1743 variant, question number 6. Uh, this question is a little typical, a little difficult, we can say even. First point is that um, I think first part is not that much tough, even second. So last part depends upon a special situation. But you can see that both particles start from the same point O on the line, okay? It means that both particles start from O. One particle goes right side and one particle goes left side. You can ask one question from me, sir, how you know? What is the logic behind? Because you can see that this is a Q particle. It is a, this above X, and I discussed many times velocity positive is the particle, this, let's say this observer. Particle is going away from observer. And if velocity is negative, so it means the particle is coming back to observer if velocity is negative. So it means this, we can understand from this negative and positive. So we can understand clear that velocity, first this observer is somewhere here. We can say that observer and a starting point is not the same. Observer this time not standing on a position of O. So both particles start from the initial position O, but it does not mean this is a observer's position. So its velocity is positive and its velocity is negative. And that how I guessed this is a P particle is coming back to observer first. This whole distance, it coming back to observer. And at this moment, it means at 10, this is a, you can say that velocity becomes positive here, positive. It means 100% confirm that after reaching here, it will turn back and it will stop somewhere here. Then again, its velocity become positive. I can guess from the direction. So this is a motion full of this triangle area while going again away from the observer. And this is a whole story. So let's try to solve the question. Okay, so first part, find displacement in 10 seconds for Q particle, sorry, for P particle. P particle mentions here. So first 10 means the full triangle, this trapezium area. And it is a simple, very simple part I. Area is equals to half into H into A plus B. Okay, so if you talk about the trapezium, this is trapezium and two sides are parallel to each other. One is called A, which is equals to 10. So this 10. One is B, which is equal to 6 minus 2 become 4. So there's a 4 gap. And whereas the gap between the both parallel sides, this parallel side and this gap is equals to 6. Don't take it negative sign, only 6. So this height is 6. So I'm going to plug in half into 6 times to A value 4 and B value is 10. And I got distance. This becomes 3. And this 14 times to 3, 42 meters. So Alhamdulillah Rabbil Alameen, we got the answer. The distance is what? So sorry, displacement. Displacement or distance same if particles going straight same direction, not turn back. So distance and displacement always equals to each other. Yes, if particle returns, then displacement is this and distance is a full. Then it changes, it's different. Okay, so displacement is equals to 42 meters. So Alhamdulillah Rabbil Alameen, first point is very clear. Okay, so then I go for part number 2. And part number 2, velocity of the P at 12 seconds. So where's 12 second? 12 second is here. I want to find what is a velocity. So it means I will just consider this line. And when I consider this line, I have many points. At this point, X is 6 and Y is minus 6. So I'm writing the coordinates 6 minus 6. Okay, sure. And what about this coordinate? X is 10, Y is 0. So I got 10 comma 0. And what about this? So this is, you can see this, x is 12 and y value I don't know. So I can find it. So this coordinate is 12 comma v1. Why v1? Because we already used. So I'm going to use, because straight line is the same gradient. Either I use these two coordinates, either I use this with this. So I'm writing here m is equals to m. M stand for the gradient. And I'm going to use two gradient formula. So first of all, I'm using this coordinate with this. So y2 minus y1, y2 minus y1 over x2 minus x1. So 12 minus 10. And now here I use both known values. So y2 minus y1 over x2 minus x1. So 10 minus 6. So v1 over 2. And here right hand side, I got 6 divided by 4 is 3 by 2. So 2 to cancel, v1 is becomes 3 meter per second. He was asking, find the velocity of b when time is 12. So alhamdulillah rabbil alameen, this point also clear. Now I'll go for the important point. Given that total distance traveled by the p during the t seconds. T seconds mean this is a t second. During motion, 49 meters given. I repeat, total distance, it did not say displacement, distance. Distance, while maybe it's going backward to observer, then go away. So this distance is total is how much? 49.5. So I can say that area of this part and area of this triangle together is equal to 49.5. How I know? Because he said distance traveled, not displacement. So total distance traveled B, but is this 49.5? It means that, and this big trapezium area is 42. If from 49.5 subtract 42, so this area of triangle, this one, I can get it easily. So distance of the triangle. So distance of a triangle formula, half into base into height. And this distance I can get 49.5 minus 42. Even I'm writing now here. So I'm writing here 49.5, 49.5 minus 42 equals to half into base. Base of triangle is this much. And I don't know this gap, so I give this name as a y, or I count as a b for base. So base and height is this is v1, which is 3. So 3. And now if I check it in my calculator, 49.5 minus 42 and into 2 divided by 3, I get b is the b means this b is 5 seconds. And this b gap, this gap is 5. So 10 plus 5. So capital T becomes 15 seconds. So alhamdulillahi rabbil alameen, we got it. The capital T value, which is exactly equals to 15 seconds. So alhamdulillah. Let's go for the next point. And when we talk about the next point, and in next point, we can look at here how to get the last part. Last part, it is very important. In last part, we have to talk about this plan. And this plan says here, especially that what is the distance between the two particles when they reach at t second stop. Okay, so let's see how we can get that answer when we have to, then they have to stop at that. So look at here. So q distance, we can get it by the dotted this trapezium. You can see, I show you again, 1 minute. I talk about this dotted trapezium. This is a distance traveled by the q particle. And after this, we can go for this turn. Okay, so first of all, distance by q part. So distance by q, half into h into a plus b. Okay, but interesting part, we have to first of all read it carefully, especially this point. I did not check this one. He said acceleration for Q is this much from 2 to 6. So 2 to 6 means this gap. It means he talk about this one. Okay. So first of all, before I use this formula, I will try to use the, and what is the coordinate of this? X is 2, y is 0. And this coordinate is what? X is 6 and y v. So 6 comma v. And I'm finding gradient y2 minus y1 over x2 minus x1 is equals to, given by him the gradient, and 1.75. And when I multiply 1.75 times to 4, and I get 7 meter per second. It means in trapezium, so I have it, alhamdulillah. So this t, I use 15 here. So I think if we talk about what is the gap from here to here, out of 15 to a 2 gone become 13. So now I use the trapezium for the Q particle. This is because t is 15, out of 15, subtract 2, I get 13. And this gap on the top is 12 minus 6, so become 6. And this height of the trapezium becomes 7. So distance traveled by the Q particle is half into h, 7 into a plus b. And this answer I'm getting half into 7 into 19. So I get a distance 66.5. Okay, when I talk about 6.66.5, so you can see this. After this, we can get the distance by the P is confirmed. I got it. Now I'm going for the so P I have already. How I have already? Because if you look at carefully, P travel distance is a, okay, file first it travels backwards, and this distance we know 42. And now I need this small distance, and that distance we know even. Okay, Q is traveling from here till here is 66.5. So if I make a plan from O, this is 66.5, and this distance is 42 meters. How come this trapezium is 42 meters? And then it turns back. You know it's turned back. So turn back, it travel, if you subtract 49.5 and 42, it becomes 7.49.5 minus 42. We got 7.5 distance. So particle Q stops here, you can see, and P stops here, you can see. And what is a gap between them? So this gap I'm looking for. So total distance is this, and gap, how much gap between the particles? So gap. So we can find gap between them so simply, 66.5 plus 42 minus 75, 7.5. I repeat, this distance plus this distance total, but this distance I don't want. So it means, now check it, what answer turned to be 66.5 plus 42 minus 7.5, and answer turned to be 101 meters. So Alhamdulillah Rabbil Alameen, this question is completely over.